lights will hit. On with the show, this is it.
Hey, welcome back, Looney Tunes. Welcome to the show. Today we're going to take a little trip to the theater, sort of. So, if you've ever gone to the theater, and this is the kind of theater that I probably would like, you get a playbill, all right? And in the playbill, you'll see the cast of characters and some other information, and you'll open it up and you can read about the characters, a little bit about the play, so you're not completely clueless as to what the play is going to be about, and you already know something essential about the characters. So that's kind of what I want to do today, is give you a playbill for the rest of the way, all right? So as we take a turn now into the first descriptive statistics and then the inferential statistics, and we start having to deal with those ugly formulas, those mathematical formulas with all their symbols and notations, I find it helpful to have all of that in one place. So let's take a look at the cast of characters. I could introduce them to you one at a time as they unfold and we need them. But as I just said, I find it nice to have them all in one place. So near the link to this video, I also have a link to a document that has all of this summarized here. So the next two slides is on a handout for you already. So anyway, let's introduce the characters and the symbols and some of the notations that we're going to be using. This is going to be most, but not all of them. All right. So. We're going to be using X a lot, and this is a big X, a capital X, and in a moment I'll introduce a little x. So X is going to be a very frequent symbol for us. All right. Now keep in mind it's never going to be a symbol for multiplication. I know many of you elsewhere you use X to be for multiplication. 2x3 means 2 times 3, all right? Since we're using big and little x's, we're never going to use it for multiplication, all right? So x will never mean multiply for us, all right? So when it's a big X, it's usually going to refer to a set of scores or a variable, right? That's another name for a variable. For us, a set of scores, a set of values, all right? So whether they're IQ scores or heights or weights or scores on an exam or anxiety or depression scores on some scale, all right? So the set of scores from our sample or from our population of data, all right, will be referred to as a big X, all right? So for a little silly example here, let's imagine we have 3 scores on something, a 2, a 4, and a 6. To make up this data set, we'll call X, all right? So that's X. N is pretty universally going to mean number, all right? Capital N will be kind of our grand total number of subjects or participants, usually, if it's a research example, or scores, data, if it's a survey or whatever. Okay, so the number in the sample, or the number, well, if it's a population, all right. I don't have it on here, but we'll occasionally use little n's, all right. Sometimes we'll have subsets. We might have a control group and an experimental group, for example, with 2 different sets of people. And so we might use n subscript 1 to refer to, say, the control group, and n subscript 2 to refer to the experimental group. All right, so maybe you have 8 people in one group and 9 in another group or something like that. Okay, so you could use the capital N to refer to the grand total of that, those 15 people, or you could use the little n's to refer to the subsets. All right, so N is simple. N is number. All right, no big mystery there. So for our little example here, N equals 3. We have 3 scores in this little set. All right. I'm going to introduce this one, these little symbols, the little subscripts I here, all right? We're never going to use them in this class again, but you'll see them in textbooks and other stats courses, so I want to just make sure that they don't throw you for a loop, all right? So that little subscript I will usually be replaced with a number, all right? So I can take on any score between 1 and however many you have in the group, somewhere between 1 and n, all right? And it would be used to refer to a particular score in the set. So replace the I here with a 2, for example. So big X subscript 2. would be referring you to the second score in this. The way I've got them sorted here, that would be the second score, the number 4. All right, so that would be that x sub something is a way to refer you to a particular score in a set of data, a particular person if it's a, represents a person. And well, we just typically won't do that. All right. I can't think of a time in this semester when I will want to refer to a particular score, a particular person. So, but some people do. So there it is. All right. So enough about little subscript I. It will usually take on a value between 1 and however many are in the set. Okay. F, and we sometimes write it with this fancy little f, sometimes just with a capital letter F. All right, maybe sometimes with a small lowercase f. Anyway, F means frequency generally. Except later in the semester, we're going to be learning something called the F test. All right, so you won't be confused when we get there. Another name for that is the analysis of variance or the ANOVA. All right, it's often called an F test, and we'll see that at the end of the semester. All right, so otherwise, F stands for frequency. All right, the number of occurrences of something. So. Not to be confused with N. N is the number of data, the number of scores in the set. F refers to the frequency of how often something occurs. All right. So maybe you have a list of test scores or something, and so you might be counting the frequency of A's, the frequency of B's, and so on. All right. So F stands for frequency. Okay. This Greek symbol is the capital letter sigma. The uppercase Greek symbol sigma. And that for us is going to be a summation sign. Okay, it's sometimes called the summation sign. And it just simply means to sum or to add whatever follows it. Okay, so we sometimes will call it, let's look at an example. We might say this, we might refer to this as sigma x. All right? Sigma x, sum the scores. That's what it means. Sum the scores, sum the values. All right. So simply add up all the scores. So in our in our little data set we're referring to here, add the 2, the 4, and the 6 together. So the sum of x equals 12. All right. It's the total. All right. The total scores. Okay. The total of the scores. Okay. So sum of x. Okay. Now. You already know about averages. You learned what an average is back in probably, I don't know, when you were about 10 or maybe even younger. And you've been using it pretty easily ever since then, okay? So as we're about to see in an upcoming video, I'm going to cover in detail the mean, the median, and the mode as measures of central tendency. Collectively, those are technically all called averages. So what you've been calling an average is a little misleading. It's kind of like calling all tissue papers that you blow your nose with Kleenex, all right? So, that's just one brand. It's just one type of tissue, but not all tissues are Kleenex. Not all averages are means, okay? So the mean is a technical term for what you've been calling the average, all right? So we need a symbol because we're going to be using the mean a lot. So this is just a symbol, a notation that's going to come up very frequently, okay? So I want to introduce to you 3 symbols that we occasionally use for the mean. Okay, 2 we will use very often in this class, and then 1 that we don't use so much in the class. All right, so when we have a big X with a line over it, okay, or a bar on top of it, we have a very creative name for that type of mean. All right, we call that X bar. Yeah, very creative. Okay, so X bar is the mean for a sample. Okay, so if it's a sample that we're referring to and not a population, the correct way to notate that for readers is X bar. That tells the reader, oh, this is a mean for a sample, not a population. If it is a population that we're referring to, we'll use this Greek letter mu. All right, that's a Greek letter mu. It's not a U, it's not an M. And as you're going to see when I start writing things by hand in this class, I'll introduce to you how I write it when I get there, okay? It looks kind of like a U or an M sometimes the way it comes out when I draw it by hand, but when you type it, it's a nice symbol. Okay, so it's sort of like a U with a front tail on it or something, all right? A U with a trunk, okay? It's a mew. It's what you get when you cross a cow with a cat, an animal that goes mew. Ba-dum-bum. Okay, so Greek symbol for populations, and this is as good a time as any to point that out. So when we're referring to samples, we'll typically use letters, regular, well, more or less regular letters. This one's a little fancy because it's got a bar on top of it, X bar, okay? So letters for samples and Greek symbols for populations, all right? So when we calculate, some what we call parameters for a population, we'll use the Greek symbol. So the mu is a population parameter, all right? It tells us something about the population. When we do statistics like the mean or a standard deviation for a sample, we'll call those statistics. This is a little confusing, I know, and it's just kind of semantics, but when we're referring to samples, the statistics that we calculate for them, we'll call statistics, all right? But when we calculate those same statistics for a population, we use the fancy Greek symbols and we use the fancier term parameter, all right? So how are you going to remember that? It's kind of simple, all right? Sample statistics, the S's go together, and population parameters, the P's go together, all right? Sample statistics, population parameters. Letters for samples, Greek symbols for populations. Dig? All right. So I want us to use those consistently and correctly, all right? Our goal in doing statistics is to clarify, always be clear, all right? We don't want to be confusing the reader. So if you are referring to something as X bar, it better be for a sample. If it's a population that you've just calculated that mean for, use the population parameter symbol mu, okay? Lastly, and this would make a lot more sense, okay? M stands for mean. So when we write APA-style papers, we'll refer to the mean with the symbol, capital letter M, all right? What could be more clear? Why not use it all the time? Get rid of these ugly, weird symbols and just use M for mean. I don't make this stuff up, all right? So it would make a lot more sense to me, too. Let's just call it, a mean is M, all right? Well, why do we use it in the papers? Well, because for the sole reason that typing an X with a bar over it is just not a key on your keyboard back in the days of typewriters. And even now in word processing programs where you can insert all kinds of symbols, I have yet, Microsoft Word has never yet had a symbol that you could insert with an X bar. Indeed, when I created this for this PowerPoint, I typed an X, and then I drew a frickin' line, all right? And if I move this text around, that stupid line stays where it is, and I gotta go grab it and move it to the proper location over the X again. So it's a pain in the nuggets, all right? So typing papers and having to insert X bars would just be a complete nightmare. So we thankfully just use M when we're typing. Likewise, unless you're using a Greek typewriter, you're not gonna have a mu key, all right? Now, it's relatively easy to insert a mu, but still, it's a matter of pulling down some menus and finding it, okay? There's not a key to press to get a mu symbol. So when you're typing, we just go with M. And that would be a lot more clear. It's easy when you're typing, and it would be clear. Mean is M. But I'm sorry, folks, we're going to be using these two symbols. So tuck that one away for when you're typing and typing papers. But in the class here, we're going to use these two symbols. Okay, we're halfway done. These are half of the symbols that we're going to use. This isn't so bad, is it? X, N, and a sigma, and a few characters for the mean. All right? What else is left? Okay? These aren't really going to be so many new symbols, but a couple of ways that we sometimes use the ones on the previous page. So x squared means square the particular score. All right? So take those scores and square them, all right? So x squared means square the particular score, or really square all of the scores, okay? Now, if you have a really super simple calculator like this, and I don't know if I've told you this, but you don't need to go buy a really fancy calculator for doing stats, okay? I don't use one. This is what I got on my desktop, okay? So, and I got a better one somewhere that I dig out when this one kind of lets me down, all right? But and one way that this one lets me down is it doesn't have an x squared button on it. So when I want to square a number on here, I don't have that feature. I don't have that option, all right? So if you're using a basic calculator ever too, just remember this. I wouldn't call it an occasional mistake that I see students make, maybe not a frequent one, but an occasional one, is when they're supposed to square a number, they'll multiply it by 2. So, 4 squared, okay? So 4 squared is not 4 times 2, right? It's not 8. 4 squared is 4 times 4. So you take take the number and multiply it by itself, not by 2. I frequently see students multiply numbers by 2 when they intend to square, all right? So don't do that. Okay, so sometimes we're going to square the scores, as you're going to learn and see. All right, and then when we do so, we'll usually add them up, okay? So we'll put that sigma sign in front of it. So this is, we would say sum of x squared. That's how we would say that for short. And yeah, sum the squared scores. Now, here's where you have that order of operations thing come and might, bite you in the butt, okay? So you have 2 mathematical operations to do here. You need to add and you need to square. It really matters in which order you do it, okay? So if you add the scores and then square that single number, you're going to get a very different answer than if you do the correct. In this case, the correct thing to do would be to square them first, square each individual score, then add them together. Very different. You'll virtually always have a very different answer. Okay, so a big mistake here is I'll see students sum first, then square. Okay. Order of operations, please excuse my dear Aunt Sally, okay? You do exponents before you do addition in that sentence, okay? So, if you need to do it the other way around, you need to add those parentheses to force you to do that first, right? Parentheses, that's the P in the please excuse sentence, all right? It's the very first thing. Do things in parentheses first. So in this case, you would add the scores first, then square that one final number. Okay, so that's a very different answer than sum of x squared, okay? This is sum the scores, then square them. All right, this isn't really a symbol. This is a notation that will, well, it's a symbol. Anyway, it's the square root sign, all right? This is the most complicated math that we'll ever do. I talked about this in another video when I told you that this was not a math course, and I promised it's not a math course, all right? So this is the most sophisticated math we'll ever do. And I go looking for the square root button on a calculator. Can you see it? Okay, the square root sign key. Even a very basic calculator is going to have that. If you don't have that on your calculator, you might want to not use that calculator. I can't imagine one not having it. But anyway, square the number under it. Okay, square root the number under it. Sorry. Okay, so. That's it. We're never going to do that one by hand, so just punch that button. Okay, all right. I've been talking about big X's so far. Here's finally its little brother. Here's little x, okay? Little x is going to mean something very different. It's related to big X, but it's not the same, all right? So don't get these two mixed up. Be careful when you write by hand so that you can tell the difference between your big X's and your little x's. I would promise to do the same, okay? So little x is what we call a deviation score, all right? It is a score minus its group's mean, all right? So let's expand that a little bit, all right? So to get little x, you take the score, the raw score, and subtract its mean, all right? I use the sample. We'll usually use sample data, so I used x bar. You could use mu for the population if you were referring to population scores. Okay, so a score minus its mean, okay? Why would we do this? Well, we always want to know how we compare with the mean, right? As soon as you learn the mean, you've been using that and wanting to compare yourself to the average, all right? When you get tests back, one of the first questions you always hear students ask is, what was the class mean? What was the mean? What was the average? Okay, because you want to know how you compare, how you deviate. This is a measure of how much a score deviates or differs from its mean, okay? If our example is height, let's just say the class mean height is 5 feet 2 inches tall. All right, so some of you are perhaps shorter than that, and some of you are taller than that. So take your height and subtract the mean, and that's your deviation score. So if you're shorter, you'll have a negative score. If you're taller, you'll have a positive deviation score. Okay, and if you're exactly 5'2", your deviation score will be 0. Okay, so not deviating from the mean is a deviation. It's a deviation of 0. Okay, so deviation scores, how the score differs from the average, differs from the mean. Okay, and sometimes we'll do those same things. Sometimes we'll be squaring them, as you're going to see. Okay, and remember, you have to kind of imagine parentheses where there aren't any here. Okay, so first you have to get those deviations, then you would square them. Okay, all right, and then we'll usually find ourselves adding them together. So sum the squared deviations. Okay, now again, note that this is a common mistake I'll see people do over here. All right, so when it's time to add the little deviation, when it's time to add the squared little deviations, okay, people will often go and grab the raw scores and square them. Okay, don't do that. Okay, make sure you know the difference between the sum of little x squared and the sum of big X squared. Not the same answer. Almost never the same answer. And I can't think if there's an occasion in this class when we would actually do this one, but just in case, if you needed to change that order of operations with the parentheses here, you would add all of the little deviations and then square them. Again, I don't think we'll ever do that, but you could. All right? So these two are very different. Sum of x squared is very different than the parenthesis value of sum of x squared. Okay. So some more common symbols that we're going to see are ones that you're probably already very familiar with. Less than, greater than, less than or equal to, greater or equal to, not equal to. We probably don't use that one. I can't think of a time when we use not equal to, but we could. All right. Plus or minus, sometimes is plus and minus. We'll see something that we're going to do later called calculating confidence intervals, when we're going to both add and subtract a value to and from another value. Okay, so add or subtract, or add and subtract, and then this one, this squiggly equals. All right, so you probably all know that one as well. You probably learned that as approximately equal to. Okay, now we're not really going to do much approximately equal to's in this class. We're learning to be Batman. Batman doesn't do anything approximate. He does everything precise, all right? But sometimes even Batman will round numbers, as we learned in the last episode, okay? We learned how to round numbers. So when we round numbers, I should have introduced this when I was talking about rounding numbers. When we've rounded a number, I prefer us to use this squiggly equals to, all right? That will tell the reader, hey, this has been rounded. Okay? So it's not, oh, this is just an approximation, like it's a guess or something. It's not a guess. All right? This will just be our symbol, make it clear that, hey, this value's been rounded. Okay? So use this when you're rounding to evidence that you've rounded something. And there you go. That's our playbill. That is our cast of characters. We're going to learn a couple more symbols as we introduce them, but they'll be on the good side of the equation, not on the scary side of an equation. Okay, we're going to calculate, like I mentioned, the F. We're going to calculate something called an F test. So F will equal some formula. T, we're going to learn T, the letter T. T will equal some formula. We're going to introduce the letter Z. All right? So I'll introduce these characters. They're going to be on the left side of our formulas. But these are going to be the values that we're going to use over on the right side, the formula side of a formula. Okay? And that's kind of it. That's kind of it, okay? So don't let this scare you too much. I promised you this wasn't going to be complicated math, and I'm making good on my promise. It's not going to be complicated mathematics, all right? Very few symbols that we're going to use, and we're going to just jerk them in slightly different or very different orientations and ways, okay? But that's going to be pretty much lots of X's, big X's, little X's, and a few other mathematical symbols, okay? And a few Greek letters for good measure here and there. All right, so, that's all, folks. See you next time.
That's all, folks.